All right, so geometry lesson 2-7, version 2. Today's date is Wednesday, October 7th, 2020. Objective. I think Emma actually beat you, Jade.
Basic geometry facts using rigid transformations.
There it is. And I only have 2 examples. Yesterday I went through 4, so maybe not as powerful of a lesson, but it looks nicer. It's nice and neat and tidy. All right, so vocab, tons of vocab. Linear pair. What is a linear pair? Kira.
It's like if you have a line and then another line crossing in between it, it's those two angles.
Yeah, it's these 2 angles. These 2 angles form a linear pair. They sum to 180. So I say that a linear pair is supplementary.
What's that?
Oh, that's a great question. That's the next word. Haha. Supplementary. So technically each one of these, well, not every single one, but most of these are a theorem. The theorem is linear pairs are supplementary. That is the theorem's name. It just means that these 2 angles add up to a certain number of degrees. How many degrees? Well, what does supplementary mean? Charles? Yep. Adds to 180 degrees. And then complementary, that adds to a different angle. What? Adds to 90 degrees. Perfect. And congruent. We've seen this word over and over again. Jade, what is it? Yeah, same size. Or maybe you want to use the word equal to. Either one of those is fine. Next, perpendicular. And again, if it's a question, Emma? No? Okay. Asha, perpendicular.
2 lines intersecting in a 90-degree angle.
Woo! We got it right today. Good job. Yes.
Yeah.
Yeah, so a line and another line that meet at a 90-degree angle. It does not necessarily have to be horizontal and vertical, as we discussed yesterday. It could be something like that still meets at a 90-degree angle. And there is perpendicular. Bisect. Emma. Not quite. That's just an intersection. Bisect is very specific. So let's say I have a line segment like this. Bisect means, well, sect, that word right here, so I'll say sect means cut. And so what does bisect mean then? Cut. So it does mean cut in 2, and now make it more formal for geometry. Yeah.
What? Line segment. Really doesn't matter what it is, but
Okay, you have to be a little bit more formal. So half is okay to say. It cuts in half. I agree with you. Can you use one of the words that is up here that maybe starts with a C, Jade? Yeah, it cuts into 2 congruent pieces so that this piece and this piece are the same length. Perfect. There it is. There's bisect. Perpendicular bisector. Joining those 2 together means what, Charles?
Perpendicular bisector is bisecting at a perpendicular angle, so 90 degrees.
So, yeah, and he made the picture with his arm, so it looks like that. So I have a line segment, and I cut it in half, and such that that line that's cutting in half is at a 90-degree angle. Perfect. Vertical angles. What is that? Vertical angles. I haven't heard from Ugo or Ulysses yet. Vertical angles. Do we remember from yesterday? It doesn't have to be the new. We'll go with Escher again.
I don't know. I'm just kind of get angles on the vertical line.
Oh, so close. So yeah, so vertical line meaning running up and down. Yeah, it's vertical angles. I don't know why they call it vertical angles. Now that I think of it, it's kind of a misnomer, which is a fancy way of saying it. It doesn't. It's not named really correctly, but it's not quite a vertical line. You want to call on someone?
Sure, Charles.
When you have a X or like a cross, the 2 angles on each side are congruent.
Yeah, so when 2 lines intersect, or 2 line segments, anything, opposite angles are congruent. So I'll say over here, opposite angles congruent. An isosceles triangle, what does that look like, Wyatt?
An isosceles triangle is when two of the lines are congruent and the base angles are also congruent.
There it is. So those two sides are congruent and our base angles down here are also congruent. I'll write down the word base angles just in case you forget. Those are called your base angles. And I'll say base angles congruent, as Wyatt said. Transversal. What does that mean? You're going to see transversal, well, you should have seen it past tense on your homework quite a few times. Like half the problems have transversal in them. I thought, only Wyatt knows what a transversal is. Uh-oh. Oh, no. Charles kind of knows. Yeah, Wyatt, go for it.
I don't know if this is right, but is it a line intersecting a pair of parallel lines?
Yeah. So I have some parallel lines, shoink, shoink, and the transversal is the one that cuts across them. So the transversal is that line right there. Maybe I can draw my arrow a little bit better. It's this line right there. And then the way that we mark parallel lines is by having that little arrow notation that says those are parallel, because my sketch, I'm not the best artist. If I was careful, I would be a little bit better maybe. There they are. Okay, so let's talk about more with transversal and parallel lines. So there's a bunch of different theorems that you can use. Some of these you've already seen definitions, like you know what the definition of vertical and linear pair are. And yeah, so we can maybe do those first. Vertical angles. Well, I don't even know. I can't really make that a question. I'll note the vertical angle. So that angle and that angle, those are vertical angles. I can say that this tiny angle and this tiny angle, those are vertical angles. I'll do 2 tick marks. Everyone can nod your head. Yeah, that looks like an X. That matches our definition. Linear pair, we can say that if I call this angle, should I use my Greek letters? Should I be fancy? Sometimes they just use X and Y, but we'll be fancy. We'll say aleph, which is the Greek letter A, and I'll use beta, which looks like that. I can say that aleph plus beta. I have to be very formal about this because I can't just say aleph and beta. That refers to the angle. It doesn't refer to the measure of the angle. So I'll say the measure of angle aleph plus the measure of angle beta is 180. Another way of saying that is aleph and beta are supplementary. Question, Emma.
Why don't you say like alpha?
Say it one more time.
How come you don't say like alpha, like A-L-P-H-A?
Oh, did I call it aleph?
Yeah.
Yeah, it is alpha. Thank you for correcting me. That's a teacher mistake too.
I was like looking at them, I was like, yeah, I was like, oh.
Aleph is, I was thinking about infinities. That is, what alphabet is that? It's not Greek. It is, I think it's Hebrew. Can we go on a slight tangent? Hebrew aleph. Did I get, no, it's not Hebrew. What is aleph? The Phoenician alphabet. Dang it. Okay. Okay, it's another letter that you use in math, but you probably don't see it until we talk about calculus or if you go to college. Yes, what?
Can you use Omicron next?
Sure. I know how to do a capital Omicron. Is lowercase Omicron?
It's just the same.
It's just, okay. So there's our linear pair. Let's go ahead and talk about alternate interior angles. Alternate interior, the best way to describe it is a Z. So I'll put like a Z above it. Alternate interior looks like this. Look at the inside angles of the Z. These two angles, we'll use Omicron. And what else do we want to use? Should we use gamma? Where's gamma? Gamma. Omicron and gamma. Omicron and gamma, so we can say that Omicron and gamma are congruent. And really the word that you should be taking away is congruent. Alternate interior angles are congruent. And you could have done it the other way too. Just because the Z looks like this, I could have done, let's use some more. Let's use epsilon and theta. I can also say that this angle, I can do a different color to make it pop out more. I can say that this angle epsilon and this angle here theta, those are also alternate interior angles. And I can say epsilon and theta are congruent, or the measure of epsilon is equal to the measure of theta.
Are you saying beta or delta? Beta.
Theta.
GAT. Oh, okay.
And then, so alternate interior are on the inside of your angles. So like inside this direction. And then I can do alternate exterior angles as well. So I can say this, let's choose a new color. This angle, I'm running out of Greek letters. I'm gonna have to start reusing some. So tau and omega. I need to use omega. Omega is used all the time. When I say omega and what do I want to use? Epsilon? Epsilon?
What about
Oh,
sigma?
let's use phi. Is it phi?
Yeah, phi is like a sideways oval with a line going through.
Oh my god.
What's the one I was looking at? Oh, psi. I was using psi. It's pronounced psi, PSI. And that's the one that looks like this. The trident, yeah. I can say alternate exterior angles are congruent. Corresponding angles, and this is the one that most people forget. I remember in geometry, I forgot this one all the time. Congruent corresponding angles, it's kind of like a translation. So if I have an angle, let's use the phi this time. I can say phi, and I ran out of room here. Another Greek letter. What do I want to use? Chi. Let's use chi. I can say phi and chi, this kind of sounds fun to say, are congruent again. I know it's fun and we're kind of getting distracted by the Greek letters, but really pay attention to where these are located. Alternate interior, they're on the inside and they were the same. Alternate exterior were on the outside and they were the same. Corresponding was kind of like a translation, we're just sliding it down. Make sure that you have these down. I mean, I'm gonna review them once we actually start proving these. Right now we can say this is a theorem, but we haven't proved this theorem yet. And I feel guilty that I feel like every single time I talk about something, I should prove it. That's about geometry. Geometry is not explaining the what, it's explaining the why. Same side interior. What should we use now? Mu, where's mu? I don't know that one. Oh, it's pronounced mu. Like Mewtwo. And Mewtwo, it's used all the time if you do electronics because it's a unit of resistance. So I'll say that this is mu.
How would you pronounce NU?
Mu is mu.
What about XI?
No, I mean NU.
Nu is, I don't know. I assume it's mu, but I'm not sure. I don't know.
What about XI?
Xi is chai.
Chai, let's use chai.
Oh God. I don't know if I can write that. My professors always did it on the, like, and every professor they'd write a scribbling like, is that chai? I don't know. That's chai, yeah. Is that, how do you, I don't know.
Xi.
You want to say xi? Okay.
Xi.
I mean, it does make sense because we always said we just replace that with a z. So xi sounds about right, right? Let me try xi. Mu and xi. Did I get it close?
That's pretty good.
Okay. That's probably like my 10th attempt in my life because I just, maybe I have a fixed mindset with writing xi. I'm always scared of writing it wrong. So mu and xi, I can say that those are supplementary. So the word here is supplementary. And you can see that, like, if they don't match up, I have a small angle and a big angle, they must add up to 180 degrees.
So also, wouldn't that be used like as vertical, not vertical angles, I guess, but interior angles?
Yeah, exactly. They are interior angles. So that's why I use the word interior. They're same side. They're on the same side of the transversal and they're on the inside, interior.
Oh.
So the side that I refer to is the side of the transversal. And then inside, interior or exterior is talking about the parallel lines. And then vertical angles, we can use the word congruent. And yeah, so it's super important to memorize the capital letters for the Greek alphabet if you go to any sort of university, four-year college, because all of the sororities, again, sororities are just for girls, and fraternities, which are for guys, or co-ed, guys and girls, both fraternities and sororities only use capital Greek letters. So if you want to go to the party and you're like, oh, it's at A Phi O, and you're like, hey, okay, alpha, phi, omega. So I'm looking for the alpha symbol, then the phi symbol, then the omega symbol. You know what to look for because all the fraternities and sororities have those giant letters like on their house. So memorize them. They'll be helpful later for college, maybe if you go there, or to a college that has an active fraternity sorority life. Let's do example 1. And I think we saw both of these yesterday, so now we're just making it a little bit more neat and tidy. I have lines A, B, and C, D. They're intersecting at point E. What theorem can we prove by rotating the plane 180 degrees? And we have 4 choices. Linear pair angles are supplementary, which is a theorem that we learned. If I add up the pair of linear angles, they add up to 180 degrees. So that is a valid theorem. Some of these are just theorems that don't make sense. Vertical angles are congruent. Again, the valid theorem. Linear pair angles are congruent. No, linear pairs are not congruent. They add up to 180. So immediately I'm going to cross off C. That's not even a valid theorem. And D, vertical angles are supplementary. No, vertical angles are supposed to be the same. They don't add up to 180. I mean, sometimes they do, but that's not a theorem. We're trying to prove a theorem here. So it's between A and B at this case. And then the correct answer is from yesterday. Hopefully everyone is raising their hand. Oh yes, the same answer. It's even the same order. If you just remember it was A or B, and he got it. There we go. It is B. It's vertical angles are congruent. Because we are rotating Z and it will map onto X or vice versa. X is mapping onto Z. Since those two angles are exactly the same, and since a rotation preserves angles, those two angles are congruent. And there's only one of these two that says congruent. All right, on to example number 2. We have line AC and line DF. Those are parallel lines. And I just made this worksheet like half an hour ago. I should have put the little arrows on these lines so we can get used to the notation of saying these are indeed parallel lines. So this is parallel, this is parallel. And then I have a transversal BE. What can we prove by translating the plane along the directed line segment BE? So somehow translating this direction. I don't know if I'm going top left or bottom right, but somehow in that direction I'm translating. Let's read through these. Okay, when a transversal crosses parallel lines, alternate interior angles are congruent. Okay, alternate interior. What was the letter that I told you to remember for that? Alternate interior angle is Zorro. It's the Z, right? It's the inside of the Z. So alternate interior angles X and Y. Those are our alternate interiors here. So can I somehow match up Y and X? Because the whole idea is they should be congruent, which means they should overlap. Is it possible to overlap or to map Y onto X with a translation? You guys should all be doing a thumbs down or shaking your head. No, it is not possible to do that. You need some sort of reflection or rotation, neither of which it's asking for. It's only doing a translation. Okay, B. When a transversal crosses a parallel or crosses parallel lines, corresponding angles are supplementary. All right, what are corresponding angles again? Maybe you have to look back at your notes. Let's scroll back up. What are corresponding angles? Let's review. So yeah, alternate interior, that was the letter Z, the armpits of the Z, I guess. Corresponding angles look like this, kind of just moving down. Ooh, moving down. Moving sounds like translating, and we're only translating. It's probably going to be corresponding angles. But look at the word that I wrote down. Corresponding angles are congruent. Look at what this letter B is saying. Corresponding angles are supplementary. So that's not even a valid theorem. That's a thumbs down. Can't do it. That's not even a valid angle. Let's go on to letter C. And maybe I should still have the diagram in there. C, when a transversal crosses parallel lines, alternate interior angles are supplementary. Well, there's a big problem with that one. Alternate interior angles, the armpits of our Z, they're not supplementary, they're congruent. These two should be the same angle. So this is not even a valid theorem, so we can eliminate C, and by process of elimination, it's D, but let's keep talking about Y. Oh, question, Emma.
you're reading it, so wouldn't that also be that, like, wouldn't that be another way to say that it's nothing to do with it?
Exactly, yeah. So we want to map something onto itself, exactly. And then D, when a transversal crosses parallel lines, corresponding angles are congruent. Well, that is a valid theorem. Corresponding angles are congruent. And can you actually get that with a translation? Yeah. So if I translate this angle FE, whatever, okay, this angle Z, and I translate it in the direction from E to B, yeah, it does map onto X. So that one is the correct answer. D. Question what?
So for C, it would only work if the transversal was at a 90-degree angle, so it can't be a theorem, so that's why it's not C.
It's a sometimes, not always, exactly. Theorems are always. Yeah, a good analysis. Cool, and there are your formal notes. We have a quiz today. Everyone did the homework except for Hazi, who wasn't here, so valid excuse. So please begin on the quiz. When you finish the quiz, you are done.